Let's look at the binomial theorem. So a binomial is an algebraic expression with two terms. So for example, if we had 1 plus x, or if we had x plus y squared, or if we had a squared minus b to the power of 4, these are all algebraic expressions that have two terms, and so they're binomials. And so the binomial theorem helps us expand binomials where we have a power that is a positive integer. So for example, if we wanted to expand out 1 plus 2a to the power of 4, or 2a minus 1 all to the power of 5, we could use the binomial theorem to expand these out quickly. So the binomial theorem states that if we have a binomial, say a plus b, all to the power of n, where n is a positive integer, then this equals to n choose 0 times a to the power of n times b to the power of 0 plus n choose 1 times a to the power of n minus 1 times b to the power of 1 plus n choose 2 times a to the power of n minus 2 b to the power of 2 plus, and so whatever terms are in between. And then our final term is n choose n times a to the power of 0 times b to the power of n, where n choose r is equal to n factorial over r factorial multiplied by n minus r all factorial. And this can also be written as n choose r in this notation. Notice how each of the powers in the terms collectively add up to n. So in this first term here, we have the powers n and 0, and so n plus 0 equals to n. Likewise, in this term here, we have n minus 1 and 1 as the powers, and if we add those two, we get n. And this is true for all of the powers in each of the terms in the binomial theorem. Another point is that this first term here, n choose 0 times a to the power of n, b to the power of 0, can be simplified to just a to the power of n, because n choose 0 by definition is equal to 1, and b to the power of 0 is equal to 1. And so this first term can be written as a to the power of n. Likewise, this last term, n choose n by definition is 1. Using this formula here, a to the power of 0 is also equal to 1. And so this last term can be written as b to the power of n. But we'll keep this like this, just so that it's clear how we're using the binomial theorem to expand these. First example is to expand 1 plus 2a all to the power of 4. So comparing this with the binomial theorem and the brackets on the left, our a is the same as 1, our b is the same as 2a, and our n is the same as 4. So we're now going to substitute these into the binomial theorem to expand this out. So we do this in the following way. We have our first term, which is n choose 0, and so in this case n is 4, so we have 4 choose 0, multiplied by a to the power of n. So in this case our a is 1, and our power for n is 4, multiplied by b to the power of 0, where our b is 2a. And then we raise this to the power of 0. Then for the second term, we have n choose 1, so in this case 4 choose 1, multiplied by 1 to the power of n minus 1, so 4 minus 1 is equal to 3, multiplied by b to the power of 1, so our b is 2a, and we raise this to the power of 1. Our next term is n choose 2, so in this case 4 choose 2, and then we multiply this with 1 to the power of 2 now, since 4 minus 2 is 2, multiplied by 2a to the power of 2, since we have b to the power of 2 here, our b is 2a. Our next term is 4 choose 3, multiplied by 1 to the power of 1, multiplied by 2a to the power of 3 now. And then our next term is 4 choose 4, so this is our final term, multiplied by 1 to the power of 0, since our a is 1, and so 1 to the power of 0 is what we get, multiplied by 2a to the power of 4, since our b is 2a, and then our power is n here. Now we can simplify each term. So this first term, 4 choose 0, if we were to use our formula here, or if we were to use a calculator, we would find that 4 choose 0 equals to 1. 1 to the power of 4 is also equal to 1. And then 2a to the power of 0 is also equal to 1. So this first term is 1 times 1 times 1. This second term now, so we have plus 4 choose 1. And again, if we were to use our formula or use a calculator, we would find that 4 choose 1 is equal to 4. We can think of this as 4 items, and how many ways are there to choose one of them? There's only 4 ways. And then we're multiplying by 1 to the power of 3, which is just 1, multiplied by 2a to the power of 1, which is multiplying by 2a. Our next term here, so 4 choose 2 gives us 6. Then we have 1 to the power of 2, that becomes 1. And then 2a to the power of 2, if we work this out, we get 4a squared, so multiplied by 4a squared. This next term, 4 choose 3, so 4 choose 3 is equal to 4. Then we multiply that with 1 to the power of 1, which is 1. Multiply that by 2a to the power of 3, which is 8a cubed. And then our last term here, 4 choose 4 is equal to 1. And then we multiply that with 1 to the power of 0, which is also equal to 1. And then 2a to the power of 4, which is equal to 16a to the power of 4. And so if we simplify further, what we now have here is 1 times 1 times 1, which is 1. 4 times 1 times 2a, which is 8a. So we have plus 8a. 6 times 1 times 4a squared, which is 24a squared. Then we have 4 times 1 times 8a cubed, which gives us 32a cubed. And then we have 1 times 1 times 16a to the power of 4, which gives us plus 16a to the power of 4. And so if we were to expand 1 plus 2a all to the power of 4, we would end up with 1 plus 8a plus 24a squared plus 32a cubed plus 16a to the power of 4. Let's look at this second example. So in this case, we have our a as 2a, and we have our b as minus 1, since 2a plus minus 1 is the same as 2a minus 1. We include the negatives when we're using the binomial theorem. And then our n is equal to 5. So we're going to use the binomial theorem again to expand this out. This is equal to our first term, which is 5 choose 0, since n is 5 here. And then we're going to multiply this with the first term here, 2a to the power of n, which is 5, multiplied by b, which in our case is minus 1. So we include the negative, to the power of 0. Our next term is 5 choose 1, multiplied by 2a to the power of 4, since n is equal to 5, and for the second term we have 5 minus 1, which gives us a power of 4, multiplied by minus 1 to the power of 1. Next term is 5 choose 2, multiplied by 2a to the power of 3, multiplied by minus 1 to the power of 2. Notice how in each term the powers are equaling to n when we add them together. 5 plus 0 is 5, 4 plus 1 is 5, 3 plus 2 is 5. That's a quick way to check that we're getting our powers correct. Next term is 5 choose 3, multiplied by 2a to the power of 2, minus 1 to the power of 3. Next term is 5 choose 4, multiplied by 2a to the power of 1, minus 1 to the power of 4. And the last term here is 5 choose 5, multiplied by 2a to the power of 0, multiplied by minus 1 to the power of 5. If we now simplify, we have the following. So 5 choose 0 on a calculator or using the formula here gives us 1. 2a all to the power of 5 gives us 32a to the power of 5, and the minus 1 to the power of 0 is just 1. Then for the next term we have 5 choose 1, which is equal to 5. 2a to the power of 4, which is equal to 16a to the power of 4, and a minus 1 to the power of 1, which is equal to minus 1. We now have 5 choose 2, so we're adding this on. 5 choose 2 is equal to 10. 2a to the power of 3 is equal to 8a cubed, minus 1 squared is equal to 1. Next term is 5 choose 3, which is equal to 10. 2a to the power of 2, which is equal to 4a squared. Minus 1 to the power of 3, which is equal to minus 1. Next term is 5 choose 4, which is equal to 5. And then 2a to the power of 1, which is 2a. And then minus 1 to the power of 4, which is 1. Next term is 5 choose 5, which is equal to 1. 2a to the power of 0, which is equal to 1. And minus 1 to the power of 5, which is equal to minus 1. If we now simplify this further, we get the following. So 1 times 32a to the power of 5 times 1 is 32a to the power of 5. This next term, 5 times 16 is 80. 80 times a to the power of 4 is 88 to the power of 4. Times minus 1 gives us minus 80 a to the power of 4. Next term, 10 times 8 times 1 gives us 80. And then we're multiplying by a cubed, which gives us 80a cubed. Next term is 10 times 4 times minus 1, which is minus 40. And then we have a squared. Next term is 5 times 2 times 1, which is 10. And then we have a. And finally, we have 1 times 1 times minus 1, which is minus 1. And so 2a minus 1 all to the power of 5 expanded gives us this.